All right, in today's video, I'm going to talk to you about how to find the magnitude of a vector. We did talk about, or I mentioned the word magnitude when I was describing what vectors are to you, because vectors have they're a directed distance. So remember, they have a direction that they're facing and they have an actual length. So the word for the length of a vector is its magnitude. So just another word for length or size. There's two different notations that can happen that you'll end up seeing when we're talking about magnitude. This one is the one that you're going to end up seeing in delta math with these two vertical bars on either side of the vector. And then just inside of here is the name of the vector. Or you can sometimes see this single bar on either side, which looks exactly like absolute value. So I'm partial actually to this double bar on either side. But this one, if you're looking in your textbook for any reason for extra help or something, you'll see this version. So delta math with these double brackets for your homework. Your textbook, if you're looking in there, you're often going to see this single bracket. And then moving forward in math, you may see either. When talking about magnitude, I want you to just know that it's not meant to be a complex thing. You've been doing it for a really long time, since Algebra 1, because it's just distance formula and Pythagorean theorem. So this vector, like we talked about, has, it's the two ordered pairs, the initial point, connecting the initial point to the terminal point, W to P in this case. Then you can also come up with the components, which is the horizontal distance and the vertical distance. So if all we're doing is trying to find the length of this purple vector, you can either use distance formula, if you like using that with the ordered pairs, or if you have the components, you can use Pythagorean theorem. So I'm partial to Pythagorean theorem, especially if it's already graphed for me, because Pythagorean theorem is pretty simple and you make less mistakes doing Pythagorean theorem versus distance formula with the subtraction. Often people will make a mistake, but either one is totally fine. So let's take a look at actually finding the magnitude of this vector. So first let's go back, do a little bit of review and name the vector. So you can name the vector two different ways, using its initial point and terminal point. So in this case, the initial point is W, the terminal point is P. So this would be vector WP with that little vector or half arrow on top of it. Or when you have a bolded little lowercase letter there, you can also name it using that. So we could also call it vector V in this case. Either one, totally fine. Then component form. So there's a couple different ways. Like we talked about, you can just subtract these coordinates if you want to. So I'm just going to do that quick as if it wasn't graphed. So you can, and you got to start with the terminal one when you're doing it this way. You got to start with the arrowed side, the arrowed ordered pair, and subtract the one without an arrow. Otherwise, you will get the wrong positive or negative value. You'll get the opposite of what you were looking for. So we want to start with the terminal x value, which is -3, subtract the initial x value, which is 3. So our x component is going to be -6. Then we would do the same thing for the y's. So the terminal y value is 6. The initial, subtract off the initial y value, which is -2. So 6 minus a -2 is +8. This is our component form. This also matches, since I have this one graphed, it also matches if we take a look here and actually count from the initial to the terminal. So starting at the initial, we would go left 6 units, hence the -6 horizontal. And then we would go up 8 units to get to that end point, which would be that +8 vertical component. So -6, 8 are our components there. So taking a look at how to find the actual magnitude. So again, if we only had these ordered pairs, we could use those and find it with distance formula. So we would plug these in and it's going to look very similar to finding the components, except for we're going to add in, the actual squaring and square rooting. So we'll take the second x value, which is -3, minus the first x value, which is 3, square that, plus again subtract the y's, so 6 minus a -2. Only thing you really have to watch for here is those of you that like to just write this -6 squared and type it in your calculator like that, because you need parentheses there. -6 squared is +36, not -36. So just be careful. 6 minus -2 is 8. So we get +36 plus 64, which gives us square root of 100. So the magnitude of vector v, or the length of vector v, is 10 units. Then you can do it with, so let's take a look at Pythagorean theorem. Should give us the exact same answer here. Again, I'm partial to Pythagorean theorem when it's already graphed for you. I think it's a lot simpler. So go ahead. I'm just going to write this down. So A and B are just your components. Doesn't matter which order they go in. Doesn't matter which one you use, first or second. So go ahead. I'm going to use the horizontal as the A. So in this case, -6. The vertical as the B. So the vertical component as the B, and that would be 8. Then just need to simplify. So again, we get 36 and 64, which is square root of 100, which gives us a magnitude again of 10, which makes sense since it's the exact same picture. So magnitude 10 for both of those. So again, that's just two ways that you can find magnitude of a vector. If you're given only ordered pairs, then I would suggest either graphing it and using Pythagorean theorem, or using the distance formula. If it's already graphed for you, it's easy to just count the horizontal and vertical components and just quick do the Pythagorean theorem.